All right, guys, let's talk about question number 4 that talks about the rational roots theorem. This question's asking us to use the rational roots theorem to find all the factors of the polynomial and graph it. Now remember, our rational roots theorem is that our possible factors, or our possible zeros rather, aka roots, are equal to plus or minus the factors of the constant over the factors of the lead coefficient. Remember that from our lesson. So the factors of our constant, well, our constant is -6. So the factors of -6 could be plus or minus 1, 3, 1, 2, 3, and 6. It's best if we have them in order. And the factors of our lead coefficient, well, our lead coefficient is actually a 1, so that's just plus or minus 1. From here, we can take any combination of this fraction. I mean, we can take +1 and -1, right? So we could have 1 over -1. We could have 1 over 1. And we could have -1 over 1. But that's just with ones. I mean, we could also have 2 over -1 or -6 over 1, right? We have all these possibilities. So let's pick one and we'll test it. The good start is usually to start with 1 or -1. Those are easy. So I'm going to start with -1 and see if it works. So I'm going to test p of -1. I'm just going to plug in -1. -1 cubed minus 6 times -1 squared plus 11 times -1 minus 6. If you've got a calculator, put f of x in, or p of x, into y1 and then evaluate it just like you know how to do using vars, y vars. Plug in a -1, test it out. So when we evaluate this, we get -1, -6, -11, -6. Those come from each of these terms. So we do all that subtraction, and -1 minus 6 is -7, minus 11 is -18, minus another 6, so -24, and that's not what we're looking for. So we just ruled out -1. That can't be. Try a different one. Let's try p of +1. Now that's going to be 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. That's a 1 minus 6 plus 11 minus 6, which equals 0. That's a good thing. That tells us, if that's true, then x minus 1 is a factor. And that's what we were going for. We're trying to find our first factor that we can pull out of p of x. Now we have a method for doing that, and we're going to use synthetic division. So let's remove that factor from p of x and see what we're left with. So if p of x equals x cubed minus 6x squared plus 11x minus 6, then when we do our synthetic division, we're going to have a 1, a -6, an 11, and a -6. And our a is 1. Going through the process, good, we got a remainder of 0, which we knew we would get anyway, because we know that x minus 1 is a factor of p of x. But the reason we did that is so that we could have our new equation. This is what's left over when you pull that out of p of x. You have this quadratic. X squared minus 5x plus 6, which is something that we can break down further. So let me just rewrite it so it's easier to see. Now we can double bubble this, and if we can't, then we'll just use the quadratic formula, but this ends up double bubbling to -3 and -2. So we've just factored this entire thing. We have 3 factors. We're looking for all 3 of the factors, and we just found them. They are x minus 3, x minus 2, and x minus 1. Now the last thing it's asking us to do is to graph it. So we're just going to make sure that we plot our zeros on the graph here. Now, if our factor is x minus 1, then we have a 0 at 1. If our factor is x minus 2, we got another 0 at 2. We got another 0 at 3. And now it's just a matter of making sure we have the appropriate y-intercept, which we know from our p of x is negative 6. So I'm going to put one at 1, 2, 3, 4, 5, 6, and make sure that my graph just accurately reflects the points that are here. And that's that.